For this problem, we want to prove that x plus x complement times y is equal to x plus y. We want to do this algebraically first and then using a truth table. So let's start here with showing this algebraically. So I'm going to scroll up a little bit here to the last page, this list of rules for hints for proving these Boolean algebra equalities. And the first thing is usually the best approach is to start with a more complicated expression and try to show that it reduces to the simpler expression. So the left side of this is the more complicated expression, and we're basically going to focus on this and see if we can show that it's the same as x plus y. So let's just start with, let's see, x plus x complement times y. Take that. And I think the first thing I'm going to do is just to put some parentheses around our multiplication here, because this multiplication would take precedence, so this is going to happen first, and this just makes it a little more obvious what we need to do here. And then we want to refer back to our list of properties of variables in a Boolean algebra, which are going to be the rules that we're using to actually do this algebra. So I'm going to switch back to this list we have. So all these properties for Boolean algebra. And one in particular we want to look at here is the distributive property. But for addition instead of multiplication, which is kind of a strange property, because down here we have the normal distributive property that you would see that would apply to numbers. That would apply just to anything in in sort of a regular algebra with regular numbers. If we have something multiplied by a binomial, a sum of two things, then we get to distribute that, and it turns into two multiplications. The distributive property for addition is the same thing, but in the opposite direction, where if we have something where we have x plus a product of two things, we can actually turn that into two additions multiplied together, which is something that doesn't make sense at all for regular algebra and regular numbers. If you try to do this with just regular numbers, it's not going to make any sense, but this is one of the unique properties that is true in Boolean algebra. And so this, if we look at it, is the same form that our problem is in. So we have x plus the product of two things, and that's what we have here. So we have this x plus the product of these two things. So according to that property, we should be able to change this into x plus the first of that product, the first part of that product, times x plus the second part of that product. So using that distributive property over addition, we get this, and this is still supposed to be equal to x plus y. And after that step, we should pretty much be able to see where to go, or maybe we have a hint of what to do next. We have x plus y right here already, and then this looks like something we can do something with. We have x plus x complement. And so again, without thinking too much about what that means, we can go back here to our list. X plus x complement is somewhere here. Yeah, the complement property, x plus x complement is 1. So we can replace this with 1. So let's say that becomes 1 times x plus y equals x plus y. Okay, so now at this point we can definitely see that this is true and that we're not too far away from proving it. At this point, we just need to get rid of this 1, get rid of the 1 times part, which again seems obvious. If we're multiplying something by 1, the 1 doesn't really need to be there, but since we're dealing with this new kind of algebra, we want to make sure that we use these properties correctly and that we're not assuming anything that we shouldn't be. So if I look over here, what am I looking for? We want 1 times something, and so we have 1 times x equals x. Okay, so that's our identity property. Works like we expect it to. We can just get rid of the 1. To be totally precise and follow these properties exactly, the 1's on the right side here, but we can use our commutative property to switch the order of that multiplication. So this is another thing where we could show the intermediate step and do everything in full detail. But if you combine these two properties, then you could also make an extra property that says 1 times x equals x. And so we don't really need to worry about doing that step by step. We can just say we have x plus y. Well, let's just do it this way. 1 times x plus y is the same as x plus y. And on the right hand side we still have x plus y, and now that we've shown that these two sides can be equal to each other just by using those properties, we're done with that proof.